Good evening, Namaskar, Hare Krishna, Jai Shri Ram. You are welcome on my channel Learn Statistics using R from Akhilesh. We shall be presenting here a series of presentations of statistical methods with statistical computing using R. And today's episode 2, the topic is data types of statistics and that of R, and along with that frequency distribution of data. The instructor is me, that is Dr. Akhileshsingh Kumar Singh. I have been ex-professor and head in Indira Gandhi Agriculture University. The presentations today includes two topics. One is data types of R and that of R. The second is what is frequency distribution of data. Presentation slide, that is that of the data type of statistics and that of R. In the very beginning, let us understand what is statistics. People know statistics by word, but there should be a definition, and what is relevant here is that this definition. Statistics in singular sense has a different definition, that is a collection of various analytical tools for collecting, analyzing and interpreting natural and experimental data in a scientific manner. Statistics actually in plural sense is nothing but the data itself. Statistics data types, wide statistics as defined in plural sense are quantitative statistics, that is such discrete quantitative data such as count of mangoes, count of males. These counts actually doesn't have any decimal value or the fractional value in between them, therefore they are called discrete. On the other hand, the continuous quantitative data actually are any kinds of measure of some trait which is very approximate, having some measurement error. For example, the Indian adult male height, say 5.7 inches approximate, or weight of fruits, say 5.75 kg, and so on. These are some approximate measures. On the other hand, the qualitative statistics may be such as the color of anything that takes value, say red, yellow, etc. Equivalent to these data types in statistics, there are many data types in R, which are, for example, integer, which corresponds to quantitative discrete data type; double, which corresponds to quantitative continuous data type; character, which corresponds to qualitative data type. For example, let us have some example of discrete data. Say word length in a poem written by Tagore. This is the reference. Anybody can go there and see on page number 176. The word length for each of 90 words in a poem by Tagore is shown below. That is, the first word is of length 5, second word is of length 4, and so on. There are 90 such instances. A solution to this is, let the word length as above is represented by as a discrete variable, say x, because word length is a discrete variable. It cannot be there will be 4, 4.5, 4.6 kind of word length may not be there. It will be either 4 or 5. Discrete because there cannot be any decimal value of word length. In R, we represent this data set of word length as by function C. This is C shown below, as we will show. The C function in R is known as a concatenation function, which means that it concatenates, that means adds up, not mathematically but direction wise. It concatenates the CSV, that is comma separated data values, into the form of a vector as follows. You see, these are the data of the Tagore word length. What we have done, we have enclosed it in the C function and put it equal to x. According to R, all these variables will be put or sent into the x variable by this C function. Above operation followed by pressing enter key at the R console enters these word length discrete data in the variable x. We shall show it how. But before that, let us demonstrate it. How do we go for that, and how do you see that? And you see, this is the RStudio. I am using at present RStudio because it is most commonly available. So what I showed you in the demonstration presentation, this is that kind of C function. You see, within the C function all the comma separated values of Tagore word length, and when we put it like this and press enter, you see what happens in the console. In the console, all these data are sent to variable x. If you can see there, you see there, if you press x, it prints like this. This is where in the presentation I was showing you how and what we mean by this. So when we press enter in R, it goes to the console and we get this kind of variables as you see, okay, like this. This means that one is starting index of this number, say 5, 21 is the starting index of this number x. I mean, there are 20 observations. There are 20 observations in the first line, and thereafter 21, 21st is started here, and up to 40, then 41 is started here, up to 60, then 61 is started here, up to 80, then 81 is started here, and so on. Let us take the example of a continuous variable. It is also from a Gun Gupta. Let the Indian adult height of 177 males in a survey of heights of Indian adult males of 177 males is shown below. Okay. Similarly, when let the Indian adult height as above is represented by a continuous variable x. It is continuous because there can be any number of decimal values of a height. Say 167 may also be understood as some value in between this range. So it is in that sense called a continuous value. In R, we represent this data set of Indian adult male as by the function C as shown below, just like in the discrete case. We had shown you. I'll show you it here again. This is in this example. You see, we have put all the Indian adult heights of 177 Indian adult males into x variable, and if I press x, you see what happens. You see, this happens. That means now this goes into x variable, and this is how x can be. If you press x, it looks like this. Let us go to our presentation. Okay. So in the presentation, this is what I have been showing. Now, this is the kind of display in the console we have already seen. Now let us take a third example, that of a character data set in statistics, postal codes of US states This is already available in the this data set of base package of R, and the reference is this. The data is like this. AL, AK, AZ are the postal codes of different states in United States of America. How do we do? Let the postal code of US states as above is represented by, say, discrete variable X. Note that the values of above stated postal codes are all characters of 2 level each. In R, we again represent it through a C function, concatenation function, and we can see like this, and then above operation, let us demonstrate it, and you see this. These are the examples. I have not put them into that because state abbreviation kind of data set is available in this. If I press it, we get this. It is already available in the base R package. So this is that data set I was referring to. If it was alone available, what we should do is that we should enclose them within string, double quotes, therefore it becomes a string. So coming back to our presentations, this is what we see. Similarly, as in case of discrete and continuous, we can also get it if we get the individual data, otherwise it is in the state abbreviation data. There are some references that we have shown. Now, second slide is about frequency distribution of data. Oh, what is frequency distribution of data? Actually is, before I start, let me go to the concept of what is actually frequency distribution of data. Suppose there are some observations. These are the observations. 5, 4, 3. I have taken a short observation just to illustrate you. 5, 4, 3, 5, 8, 6, 6, 3, 4, and so on. If we want to really arrange in a systematic manner, what we can do, we can distribute these into a distinct set of observations. If you note here, there are observations 3, 4, 5, 6, 7, 8. So we can systematically write them like this: X, 3, 4, 5, 6, 7, 8. These are these distinct values of discrete nature. Now, if we have to summarize it like a frequency distribution, what we mean is we distribute this according to these distinct values. For example, 3, see the blue arrow. Against 3, I have put down a vertical tally mark. Another 3 is here, here. This another 3. Another 3 is here. All the blue ticks are put like this, whose count is 3. That is its frequency. We call it frequency. Frequency means the value of repetitions of a distinct observation. So 3 is repeated 3 times. That means 3 is repeated 3 times. Similarly, if you see 4 by the red arrow, so red arrow is has 4 vertical tally marks. That is, 4 is the frequency, that is number of times 4 observations repeated 4 times. And if you go to 5, 5 is with magenta color, so it is repeated 3 times. That means 5 has a frequency of 3. 6 similarly has a frequency of 2 with 2 tally marks. And there is no 7, so it has 0 frequency. 8 is repeated twice, that means the frequency of 8 is 2. This is the concept of frequency distribution, and this is what we mean by frequency distribution. Now coming back to our presentations for frequency distribution. So what we have shown you, actually we can have a definitions of that kind. Frequency is the number of times a distinct value or the class of variable is repeated is called frequency. The total number of such number of times for different distinct values of the variable is called total frequency. The pattern of this total frequency is called frequency distribution. This is what we mean by frequency distribution. Let us go to have some example. So computing frequency, total frequency and frequency distribution of discrete variable for the same set of data of the word length by Tagore. So let us do its software demonstration. So this is the so far I had demonstrated you this much only, okay, how to enter into X variable. We suppose we do it, we have already done, press Ctrl Enter and the data goes here, just confirm it, X is there, okay. So coming back to our presentation, so here in let us use following R codes for computing frequency, total frequency and frequency distribution of word length. This part we have already done as I have shown you in the RStudio. The second part is computing frequency of distinct values. So how it is done that? We use a function, R function, that is table of X. So if we exercise this, we get this much value, okay. And another important thing is that we should know what is the structure of this table X that it is created. So let us go back to our software demonstration, where we shall see in RStudio that if I press, because X has already been entered, I am doing it again, okay, then table X, I am bringing my cursor here and table X. So this is what has been computed. It means that distinct values of Tagore word length in poems are distributed from 0 to 12. That means there are a distribution of 12 kinds of words. A word of 0 length is 1. A word of 1 length is 1. The word length having 2 are repeated 10 times. Word length having 3 are repeated 19 times. Word length having 4 are repeated 20 times. And so on. Word length having 12 letters are repeated only one time. So coming back to our presentation, what we see there, a structure has got these values. What does it mean? Let us go back to our software demonstration. In this structure, if we press, we get this. This says that it is a table. The structure of this table X, you see, table X, table X. Structure of this, str means a structure. That it has got 2 rows. One is table of 1 by 12, 1 dimension, containing 1, 1, 10. These are the actually frequency values. You may note that these frequency values are integers. Whereas the second is a list of again 0, 1, 2, 3. I mean these one. This is shown here just like a discrete value, but it is not actually. In the structure you see that these are all quoted within quotes. That means they are character values. I mean these are the character values and these are the numerical values of discrete nature representing frequency. These are the character values representing the names of these frequencies. Okay. So coming back to our presentation, presenting the distinct values and frequency in a say word length. Word length, I am giving this quote, word length equal to names of table. That is the names that were quoted by 1, 2, 3, 4 in the double quotes. This name function, what it will do, will be extracted from this table X and will be put into word length, storing names as word length. And table at as vector, the frequency values will be stored in by just putting as vector. So we have now the names in the word length and frequencies in this. Let us create a data frame. What is a data frame? Data frame is a kind of table where the first column will be stored as the word length and second column will be stored as F having frequencies. Let us do this calculation there, and thereby finally in the frequency distribution we will get this. And when we sum this frequency distribution F column, you see frequency distribution $F means F is a column of frequency distribution data frame. So it is specifying that you sum the frequency so that we get its total, and that will represent as N. Let us demonstrate it in the software distribution demonstration again. So after this, what we have presented there, the first command is, say, this one. That is, we have stored names of the table X in word length. You can see here what word length actually is. In the console, it gives you a character names. You see these character names. And frequency, when we control enter there, we get, say, in frequency, we get these are the frequencies. Now if we put these into data frame like this and take an output, you see this. What it has done, data frame function has combined these two columns like this here, you see, as X and as F. This contains the word length, this contains the frequency. And this calling of this is actually calling that same thing. Okay. Now, if we want to sum this this column only, because we want to know what is the total frequency. So what we shall do is, we shall call this data frame frequency distribution $. $. is a special symbol which tells you that first part is the name of the data frame, the second part is its column. This by data frame, this column is called into the function sum, and thereby it is summed into and put into variable n. So if we call it, we get 89 is the total number of word length data. Okay, let us go to our presentation. So taking the second example of Indian adult male, that of the continuous data. These are the full data. Those who want to copy it can copy it. And again, this is how we shall be doing. We shall be putting them into C function, and we will get, let us do first in the software demonstration. Okay. In the software demonstration, this is that. So again, let me enter this into the console. It has gone there. Now coming back to this, you see, if we call it X is like this. These are the heights of Indian adult male. Now, as we see, we have done this part. Second is, for creating a frequency distribution in a continuous nature of data, what are the necessary steps? first find maximum and minimum of the x, that is range of x. That is done. You see, this is a C function where we are inputting minimum function and maximum function, maximum of x, minimum and maximum of x will be obtained. That is obtained here. This is minimum, this is maximum. Another is after semicolon range of x. It directly calls the two minimum and maximum. This is the same as these ones. And then we want to calculate the width, that is maximum minus minimum. If we do like this and call width, so all these four commands 1, 2, 3, 4, 5, 6, 7, ultimately width will be calculated as 37.9. Thereafter what we shall be doing, the minimum value of x, we shall find the floor of this. For example, the minimum value of x is 1.145.6, so its floor value will be 145. And ceiling of maximum is, for example, this is the maximum value of the data. So its ceiling will be not 183, it will be 184, just above that. Okay, so the purpose of that will be clear just afterwards, because you see, we have to find class intervals as we have demonstrated in the definition of the continuous data. We want to create class intervals so that these data is included into that. If we take the minimum of that, this 145.6 will be included. So we will be taking a range of this from 145 to 180. We shall be creating a sequence of. So we shall create five sequence that R will automatically calculate. Similarly, for upper limit, we have to get the from 150. You see, 150 is the ceiling of this, and 185 is the ceiling of this. Okay, we have rounded, actually is 184, but we have rounded up to 185 to get better observations. So let us demonstrate it. How do we do that? So here we, if we press this, you see these are the values. First, the minimum maximum are put like this. Range of x is also computed like this, same thing. Width is maximum x minus minimum x, and then we call width. So this is that. We have already discussed that in our presentation. Now floor and ceiling of this minimum and maximum are 145 and 184. Then we want to create class intervals. So let us say class interval of lower type and class interval of upper type. So there is a sequence function. If we give minimum and maximum and say how many intervals have to be created, it will compute. Similarly, 150 to 185. Why 150? Because with the class interval of 5, the next limit will be 150. How? I can show you like this. You see, if we say 145, we 145, then this is up to 150, then 150 to say 155, then 155 to say 160. You see, there is a 5 interval. So these are the CI lower level type. These are the CI upper level. 145, 150, 155 will be CI class interval of lower type. These will be class interval of upper type. 150, 155, 160. Okay. So with this concept, let me go back to our computation here. So class interval CL, CIL and CIU are computed. You can see what does CIL contains. You see, these are 145 to 150 to 155 and so on. Similarly, if you see upper one, so this contains 150. You see, this is the, so 155, 145 to 150, 150 to 155, 155 160, 165 to 165, 165 to 170, 170 to, and so on. These will be our class intervals. So based on these informations, we compute breaks. You know, breaks are like this. From these observations, we compute breaks. How? 145 is the first one, second is 150, third is this, and so on up to 185. These are the breaks. Okay, 145 lower one, and all these are same as here. So this one, all these are break values. So if you compute this, you say these are the break values. We need these break values. Now coming back to our presentation for the time being. Coming back to our presentation for the time being. This is all we have computed. Now this is what are the class intervals that we have to compute. How do we do that? We have already computed the breaks there, we have shown it there. Now we cut these intervals are cut from the total number of observations by using cut function, which takes the original x variable and this breaks vector, computations we have done, and then if we compute, these are the class intervals. Okay, so how this is, we will be representing in our lecture, software demonstration. How you see this? So we cut it and we get this. What does it mean actually? You have to understand it. There are so many observations, you see, 169. This 165 to 170 means that 169 is contained in the first interval. Okay. Similarly, 166.7 is contained in the second interval. This one. You see, 166.7 lies in this range. 159.9 lies in this range. So what R does, R creates corresponding intervals, class intervals, corresponding to each observation that are in the X vector. This is very important to understand. So let me go to our presentation. This is what we have computed. Now what we are going to do, now we can create frequency distribution of these cuts intervals. We can see that there are so many, you see here, there are so many these intervals, but they are actually not so many. Each interval is repeated so many times that we shall be finding how many times these intervals are repeated. We shall see that this interval is repeated 1 time, this interval is repeated 3 times, and this interval is repeated 29 times, and this maximum is repeated 2 times. Okay. Similarly, as was in the case of discrete, we shall find its structure, and we will similarly find that these are the frequencies, and these are the class intervals because they are of the continuous data. Then we can similarly find, as was in the case of discrete nature, the names of these, they are class interval names that will be enclosed within quotes like this, and then we can find our frequency distribution. And similarly, in the last, we shall find a data frame, just as was in the case of discrete distribution example, and we will now find frequency distribution. Here we are introducing another function that is called transform. What that will do? That will do to add these 2 columns to the data frame that we have computed here. So if we have to add certain columns, we need to use transform function, and finally when get our frequency distribution, it look like this. And when we want to find the sum and total frequency, we can add this F column like this. That is, from this data frame, $F column will be summed and added to an observation, so that we will get 177 observation. Let us do it in our presentation, software presentation, and where we can see that we have computed up to this cut CI we have done. Okay, cut we have CI we have. Now we'll compute this table, that is frequency distribution. In the presentation I have told you these are repeated 1, 3, 29 times and so on. Then we compute the structure of this table, which says the structure function is very important, because if you understand the structure of a data frame or of any data object in R, you will not do mistakes. Otherwise you are liable to do mistakes. Therefore I am introducing this structure function. Okay, so it is a table of say first one dimension is of frequency data. The second is names, observations. They are stored as dim names within double quotes. Okay, so after that what we will be doing, we shall create a data frame by adding CI names as we have computed here, class interval names. Class interval names are these data, okay, and class interval names and this frequency that we have already computed here in the frequency. Okay, these are as vector. If we do as vector table C, we get frequencies, that is these observations. Then we added them into this frequency distribution table, that we get like this. I am sorry, we did not compute, therefore error was reported. So we have to compute these. After that it will add them. So it has added the class names like here with their frequencies, which means that these intervals are repeated as many times as are their frequencies. Now we want to add the class, lower class interval, upper class interval in a very systematic manner, which are amenable to or easy for computations. So if we do like this, we get this. So these class intervals are repeated in different columns here as a numerical values. 145, 145, 150, 150, 150, 150, 155, 155. These are the character values. The first column is character values. You cannot use these as the basis. These are for demonstration only. F can be used for computation. These lower class limits can be used for computation. Upper class limits can be used for computation. That is why I use these techniques. And if you want to find the total frequency, we can do like this. Okay, so now we will go back to our presentation. Now we shall be taking a third example. These are those of the postal codes of United States. They are such as AL is a postal code of a state and so on. These are we don't need to actually enter. They are already in the base package of R by the name of state app. I have already demonstrated that. Now here we want to find the frequency distribution of this data, and this is very simple, and we will go similarly as earlier. So I am finishing this one. Now let us go to our software demonstration. Here in the software demonstration, if we take the US, this one, state tab is already there. If we get its table, that is frequency distribution, since each postal card is unique, therefore each one has its frequency as one. So this is not surprising. Okay, so if we get a frequency distribution, it is like this. For the, this is example of character type of data. And if we want to have a total of these 50 demonstrations. So let us go back to our presentation. So here in presentation, this was the last slide that we obtained. Now there are some references. So I want to finish my lecture here, and I wish to thank you. Namaskar, Hare Krishna, Jai Shri Ram.